Welcome to the OscopeWizard. Just like the video says, welcome. Thanks for joining me in the techno lair. New mics, new camera lenses, new everything. We're making this happen though. We're making this happen. It is Tuesday, May the 19th. That means the last time I was out on the roads in a car was over 2 months ago now, on March the 17th. 2 days past May the 17th. It's been a while. It's been a while, folks. Everybody's feeling their feels. Everybody's getting it done. Everybody's trying to move forward in this new reality. Happy Tuesday to you as well. Thank you for joining, Mr. Lewis. Who else is on this morning? It looks like there's a couple of us. And I'm really excited because the last couple of episodes have been about probes. Probes. I kept opening a drawer and pulling out a new probe, and we may go back to that, going back to pulling probes out of drawers and examining them. But today we are going to begin a quest that I have been thinking about for quite a while. I really like quests. I noticed that most of the shows that me and the kids watch together are our favorite ones are quest-based. They're like Troll Hunters on Netflix. If you haven't checked out Troll Hunters, do yourself a favor and watch it because it's incredible. We are big fans of She-Ra, another quest-based show. We just finished The Last Kids on Earth, a third quest-based show. I mean, not all quest-based shows are hits. Looking at you, Dark Crystal, you're a little too weird for us. But still a quest-based show. So today, beginning a quest of our own. We're going to make the OscopeWizard a quest-based show. Now, we won't be fighting off monsters and goblins and trolls and ghosts and zombies. We will be fighting off bad engineering, terrible ideas, and probably humor all at the same time, because I am doing my best to kill humor one show at a time. I did have some things to talk about, though. Let's see if I can turn it on. The last time I was on, I pulled out my trusty orange speaker, which I have had for, I think, 10 years. It might not be 10 years. It was a original Ultimate Ears mini boom. So if somebody Googles that and finds out when it came out, I think I got it when it came out. So it's pretty old. And I pulled it out on the last episode because I was going to be all showing off the EMI emissions coming out of it, which is one of my favorite demos. I've been doing it for years. I have carried that speaker with me on countless demos to countless customers, and spent countless times listening to it in the driveway, in the backyard, at the beach. Died. This speaker, it passed away. It passed away on the last episode, live on the OscopeWizard show. Of course it died on the OscopeWizard show because life. So originally I gave up on it, but then I thought, you know what, let's tear this thing apart. Let's tear this thing apart and see what's inside, see if it's something that's kind of easy to fix. So I pulled off the orange section, and then I opened it up and I looked at it, and I was wondering, like, where is the battery on this thing? It did have what I thought was a pretty good size subwoofer. I was kind of excited. Turns out that was just a passive resonator, which means, I mean, honestly, it's a pretend speaker. If you see passive resonator, what you are reading is pretend speaker. But yeah, it was a rip moment. Rest in peace, orange speaker. So it had a passive resonator. Finally got it opened, trying to find the battery. Found the battery. Of course, I'm thinking, you know, I'll just replace the battery because that's the lowest hanging fruit. You can buy a new battery. It was kind of I'm not sure if anybody other than my nerdy self would want to crack it open. I posted it on Facebook. Of course, I'm friends with nerds, so they were all like, did you try this? Did you try that? Did you do this? I did not do anything except try to replace the battery. I found the battery, looked at the battery. It was a lithium-ion battery, 3.7 volt. Pretty standard lithium-ion battery. It turns out I had another lithium-ion battery in this little wireless keyboard. I just right here. just another lithium, not the same capacity, but the same voltage, which is what was important. I pulled it out and did things that you're not supposed to do to batteries, which is solder some leads to the contacts. Don't do that, children. Plugged it into the speaker thinking this will work. Didn't work. Didn't work. So honestly, I feel like I did everything I could for that speaker. It was with me a great deal of my life, and I really appreciate its service. Now it's time to move on to a new speaker. I have one on the way. We'll see how it behaves, if it can give me hours and hours of enjoyment at beaches, backyards, and barbecues, and basketballing. These are all the places where I loved it. Also, professionally, maybe I can use it for demos, because I actually do quite a bit with speakers in my demos, because why not? Why not? Let's make it fun. Now, after the chit chat, did anybody else lose a speaker while I'm here? Did anybody have a bad speaker disaster over the weekend? Hopefully not. Hopefully I'm the only one who lost speakers. I know weekends are not a place where you want a disaster, but disasters often have a habit of finding weekends. Disasters love to find you at your most relaxed, when you're not looking for it. I remember one day, fairly recently, I'd gone to play basketball. I used to play basketball very early in the morning, 6:30 in the morning. I had this run. We would play from 6:30 to 8:30 or 9:30. Went, had the run, great run. Came back, got out of my car in the garage, in the basement, stepped out of the car into water. Now, generally speaking, one does not want to step from their car into water because it is not a boat. And generally, when you're in a boat, you also don't want to step into water because that is bad. Really bad inside the house, really bad. Not a great way to start the morning. I was super relaxed, ready to have a wonderful day. Disaster. Disaster struck. So maybe the key is to not be relaxed, to always be like on edge and waiting. That's probably not the key. And don't live that way, get some joy in your life. So, quest, what are we talking about this morning? I said that we were going to have a quest. This is our quest. I bought, because I'm prone to buy, I bought a broken amplifier on eBay. And this, it drives Mrs. OscopeWizard crazy that I keep buying broken things, because I watch all these videos on YouTube thinking that I can fix it, because I see these guys, they make these videos and they'll fix this piece of electronics, and I'm like, I got a soldering iron and some clippers, and got one of these things, wire strippers, we can fix some stuff. But the truth is, I think those YouTube videos might not show every single failure that they have on fixing things. I don't know what their fix rate is. So far, my fix rate with broken things off of eBay has been low. Let's say low. Not 0%. Not too many places above 0% though. So we're hovering around zero. If I was to quantify this as a batting average for a major league ball player, I would not be on the field if that was how that correlated. So yeah, you watch these guys on YouTube and you're like, they can fix it. I mean, I watch them fix all kinds of crazy stuff. It turns out that might be a skill set that I do not have. I mean, right now, I have a broken graphics card that is sitting on top of my printer. I don't have hopes of fixing it, but I'm like, I don't really need the graphics output of it. I just need it to process data. So maybe I'll just slap it in my server and see if it works. So right now, don't tell anybody. Shh, don't tell Mrs. OscopeWizard, because she might find out. I have this that I bought off of eBay, hoping that I could resuscitate it. Let's call it resuscitate. All that to say, I bought a Sonos amplifier, thinking that I could fix it. And I have it up there on the screen. You can see I paid real money for it. I think I paid $80 for it. Messed around with it. Did everything I could think to fix it. As far as I tore it apart, I found the debug port, the JTAG debug port, which is a digital debug port that we will not use most likely on the show today. Was talking to it, emailing with service. Ultimately, what it turned out was Sonos has a recycling program that is not recycling. It is the opposite of recycling. But if you buy a Sonos product and you want to recycle it for a discount, you can call them and they will send a kill code to your product that you currently have, and they will kill it dead like a doornail. And then they will give you a 30% discount to a new product. It is a disturbing turn of events, but also it means that eBay was flooded with all of these dead Sonos products before the program was widely known. And I had one of those products that was, dead on arrival on purpose. So it was, I think, upcycled, more like just trashed. Just trashed. It's a fancy way of saying trashed. So after working with it for quite a while, I kind of gave up on it. But I didn't totally give up on the idea of making an amplifier. It kind of inspired me to let's see if I could make an amplifier. I always want to try to make something. I have busy hands and I just need to keep them occupied. So with that in mind, I purchased some new things from eBay. Now, these were not broken things. These were actual things that presumably do work. I bought this board right here, which is an amplifier. This is supposedly, we're going to find out, supposedly a dual channel, so 2 amplifier chips under here. We'll pull this heatsink off and we'll see. And each amplifier chip should provide 100 watts of power. So that means in this little tiny board, which is the size of my palm, is a 200 watt stereo amplifier, which is actually more than the Sonos amplifier. Originally, the Sonos amplifier is rated for 50 watts. It's not all about the wattage when it comes to audio amplifiers, I understand that. But that is still an impressive amount of power to pack into this little guy. And then I also bought some other bits and bobs. I had a Raspberry Pi Zero, and I have a tiny board that goes from a protocol called I2S, which is a digital audio protocol, and it is a digital to analog converter chip. So it's a DAC. That means it takes the digital audio in I2S format and outputs an analog audio system or signal. And I can send that analog audio signal to my amplifier, or this is all theoretical. This is hypothetical and theoretical. Send my analog audio signal to my amplifier and make my own Sonos amplifier. I think I can make it. I think we can have this quest together of building a Sonos amplifier from scratch. And you know what I did not do? I did not start my timer. But I do have a watch. I do actually wear a watch, and I should be able to keep track of time. I am a grown adult. Keeping track of a time is a basic life skill that I seem to have lost. I'm going to work at it. What do we think? What does chat think here? Let's see. Those annoying electronics YouTubers are really good at editing. Those electronics YouTubers are so good at editing. I mean, they must buy tons of broken stuff off eBay, attempt to fix it all, and then edit 4 videos, or let's assume 1 video a week. And so you think they're fixing everything, and they're probably throwing most of it away. I will say that I noticed that the guys who are fixing things on those YouTube videos, usually they're like, you know what, I'm fixing this PlayStation. Let me go get the 8 broken PlayStations that I have in my garage and use them for parts. So that means, sure, they're fixing the 9th PlayStation, but on 8 other occasions, they just bought broken PlayStations that sat there. Let's see what else we got. Oh, yeah. I remember when you couldn't just order a replacement electronic parts. I do remember that. I remember the time when you had to go to a store or even order from a catalog. Maybe if you were trying to buy components and you lived out in the country, like where I grew up way out in the sticks and the boonies of South Georgia. There was not a Radio Shack for me to go buy electronic components. It would all have to be mail order, of course. This is before I knew what I was doing. There is some question on what a PlayStation is. Oh my goodness, I don't even know how to address that. That is a video game console that you should probably be aware of, as it is a part of pop culture everywhere. Let's go to the bench and figure out. Actually, before we go to the bench, let's look at some data sheets, because I thought when I bought this stuff we should begin with data sheets. That is a good place to begin. You can see it's all laid out on the bench here, and we're going to use some power supplies. We're going to get it up and running, and we're going to slowly but surely figure out what these products can do, and can I make a homemade amplifier for my audio. I'm kind of cheating because I got a board, but seriously, people, if you don't get a board, it's going to be a nightmare. Here is my screen. Make it nice and big, and I have we'll start with what I have. This is what I have currently. I have a very old JVC MXKA3, which has a tape deck and a 3-disc CD changer, if you can remember the CD changers from a million years ago. Before MP3s, we all used to, I remember I had a car, I had a Nissan Altima that had a perpetually broken alternator, and I became very good at changing alternators. And inside of that car, I had a 12-disc changer that was most of the time jammed, but when it wasn't, it was glorious because I could choose between 12 discs. And on those discs could be MP3 files. I thought it was hot stuff. I could load 12 discs full of MP3 files and basically have a radio in my trunk. Now, we all have full radios in our pockets and with our smartphones, so not quite as impressive. But this guy had a disc changer, just, you know, a small aside. So this is what is powering the speakers that are currently blasting music in my driveway. It's not bad. It's not a bad system. It is very stolid. It's not exciting. It kind of has a weird bass response, and what it does do is turn on and play music very consistently. So in order to replace it, I would want something that is just as reliable. Homemade amplifier may not be just as reliable, so when I finish this, I probably won't just throw away my old JVC. They're trying to figure out what is a PlayStation. Nintendo for millennials. That's a pretty good joke. Specifications for the JVC. So the JVC that I have right now is 80 watts per channel. I bought a broken Sonos that was 0 watts per channel, but it was specified at 50 watts per channel, so it was going to be 30 watts per channel less. But the response was going to be wider, so oh, sorry, that's the cassette deck response. Let's see, does this show the response? It does not show the frequency response. Okay, so the speakers on the JVC are specified from 45 hertz to 22 kilohertz. So that is most of the human hearing range, the human hearing range is generally spec'd as 20 hertz to 20,000 hertz. That's usually. I'm getting lost in the chat too. I think we're good. Chat's good. They don't need me. They're handling their own business, which is wonderful, guys. Hang out, chat. It's good. Let's interact as humans. One of the things that I am curious about is that the JVC says that it'll do 80 watts per channel, but then it could have up to, it says no more than, but up to 10% total harmonic distortion. If you have that much harmonic distortion, you'll hear it with your ears. It'll sound, you know, distorted, muddy, tinny, weird. Wrong. It'll sound wrong. That's what I have now. So 80 watts into 2 channels, so 160 watts total. I am replacing it with this little chip. I hope I am anyway. That's what is supposedly on this board right here. Uh-oh, lost me. Let's bring me back. Bring me back, come back, wake up. Supposedly that is what is on this little demo board, or not demo board, but actual amplifier board. So it is the TPA 3116D2 amplifier chip. It is a Class D audio amplifier. One of the big differences between what I had, which was the JVC, this guy is going to be a Class AB audio amplifier, which means that two things are true. It will be bigger and it will be less efficient. So when audio signal, or when power is sent to a Class AB amplifier, a lot of that power is lost to heat. So that is why old amplifiers will be really big, and if you hold your hands over them, you can usually feel heat actually pouring off of them, because a lot of the power is not being sent to the speakers, but is actually being used to generate heat. I mean, that's not on purpose, but that is just the way the AB amplifier works. The Class D amplifier is super hyper efficient. It is much smaller because it doesn't have to take as much area. There are a few components. It's all on a single chip. And almost all of the power that is pulled into the amplifier is sent to the speaker. So it's very efficient. But let's kind of compare the amplifiers. So this thing says it'll do 2 by 50 watts. Or you could wire it up to do 1 by 100 watt, which is supposedly how this amplifier is wired, to do 1 by 100 watt. It operates from 4.5 to 26 volts, which is good because I plan on using a big 12 volt power supply that I had sitting around, because now I'm one of those YouTubers that just has a bunch of stuff sitting around. Of course I do.
5 minutes remaining!
5 minutes remaining, guys. I noticed my watch was telling me there was 5 minutes remaining, so I thought I would take a quick break there and point out that I realize that we have 5 minutes remaining, but we're going to still continue into this data sheet a little bit because the data sheet is actually going to be important for us as we try to build this amplifier. So I am going to do 1 by 100, I think. I'm going to power it with a 12 volt power supply, and let's see, it has a standby function, so it can actually be put to sleep, which will be good because when it's put to sleep, it should draw hardly any power. When it's powered up, I don't know what the power consumption is at just on but not playing. And let's see. They're asking, what is the power supply? Can it be powered by D batteries? Would you believe that over the weekend I did a quick test here of my amplifier, and I powered this guy with 8 AA batteries. And with 8 AA batteries, it was able to generate some sound. And I did that to make sure I just wouldn't smoke everything on live TV. But it does work. It does make some noise. And maybe in the next episode, we're going to go back to the data sheet, see how we have it all hooked up. In the next episode, we're going to get some sound coming out of this amplifier. Also, we're going to pull the heatsink off to see what's under it. Like, how many chips are there? I think there are 2 chips under it, but I've not pulled the heatsink off, so I don't know for certain. And then, once we get sound coming from our amplifier board, we are going to work on the digital section. So we're going to start with the analog section, so sound in to sound out. And then we're going to move over to the digital section, which is going to be our Raspberry Pi and our I2S digital to analog converter chip, DAC. And I'm really curious because this DAC is allegedly 32 bits, which I don't know how that relates to the number of bits coming into the I2S channel. Is it more bits if it's going to be more detailed? I don't know. We're gonna do a little bit of experimenting because I have an oscilloscope and I can actually look at that digital bus. So before I go, let's check the chat, make sure I did not miss anything. Last time I missed a really funny joke about Hot Tub Time Machine, and I was kind of felt bad. But if I go back over this, there was a question about the the guy on our the main page of let's see, the company that I work at. I work for Roda and Schwartz, and if you go to our oscilloscopes, wake up, test and measurement, oscilloscopes. This guy right here, he does look about 7 feet tall. He does. That is without fail. He does look very tall. Then there was a question about PlayStations, and I love the joke of PlayStations are Nintendos for millennials. That is hilarious. There was a question about using the amplifier with D-cell batteries. Made in jest, but you could if you had a bunch of D-cell batteries. I do not have a bunch of D-cell batteries. I have a bunch of AA batteries. And then, do I have anything that can measure the current draw when it is active or asleep? That is a great question. And in fact, yes, I do have something. I have two things, in fact. I have a multimeter that could do it, and I also have the power supply itself can measure the current draw. And third, I have an oscilloscope that can measure. So I have 3 ways to measure the current draw, both asleep and awake. And I do plan on trying to figure out what the awake current is versus the sleep current. And eventually, I hope that the amplifier can put itself to sleep when it's not playing sound. I am going to be hanging out on chat for a couple of minutes after this to answer any questions or just to joke around with you guys. If you could do me a favor, please share this with a nerd in your life. I don't know all the nerds in the world, but I would love to meet them. You know what? If you want to let me know what you think, just drop a line in the comment section on the video after it's posted, and let's continue the quest. We are going to build a Sonos amplifier from scratch at the house in the techno lair. At the end, I'm going to play it in the driveway, and we'll do a live stream out in the driveway. That'll be a lot of fun. Thank you so much for joining. I will see you guys next time.